All right, here's section 6.5, and what we're looking at is graphing square roots and cube root functions. Have your calculator handy to help you with double checking your math and things like that, but these are some graphs that you should be able to do by hand. And one of the things that we're going to do is just recognize a general shape for these graphs. You need to know what you're looking at. So in black we'll do the square root of x, and remember that with square root of x you can have no values of x that are less than 0. So with the square root of x, we're simply going to look at numbers starting at 0 and then staying positive. So I'm going to go with 1, 4, and 9. And I'll tell you why I'm going to do those in just a second. And then with the cube root of x, we can have positive or negative numbers with the cube root of x. It doesn't matter too much one way or the other. So I'm going to go with negative 8, negative 1, 0, 1, and 8. And again, I'll show you why I picked those specific numbers. And the most important part here is to get an idea of what the shape of the graph looks like. Okay, so back to the square root function. When I put 0 in for the square root of x and I take the square root, I get 0. So that's not too bad. When I put 1 in for the square root of x, the square root of 1 is 1. And that's not too bad. Then I put in the square root of 4 for x, and I get 2. And that's why I picked the 4, because I knew that it would be an even square root. And then lastly, the square root of 9, which is 3. So when I graph this guy, I'm looking at a graph that has 0, 0, 1, 1, 2, 3, 4, 2, and then 5, 6, 7, 8, 9, 3. So here's what your square root function is going to look like. Just a little gentle curve. Whoops, I missed both of those. Isn't that great? But a little gentle curve that looks about like this. Doesn't go below the x-axis, so the domain on this guy is going to go from 0 to infinity. And the range on this guy is also going to go from 0 to infinity. They will not go below the x or y-axis in its parent form, the parent function, the base function, the beginning function, the starter function, the square root function from which all other square root functions come from, the parent. All right, so now looking over here with the cube root function, the cube root of negative 8 is 2, and that's why I chose that guy. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So when I graph these guys, I'm going to go x at negative 8. So it's way over here. And it's going to be down 2. About right there. Then I'm at negative 1, 1. Then I'm at 1, 1. Then I'm at, or that was 0, 0. Then 1, 1. And then 1, 2, 3, 4, 5, 6, 7, 8, 2. And so this makes a little curve that looks like this. And that's the base cube root function. And how these work is I can move these guys up and down, left and right, backwards and forwards, and it's still the square root function. It's just been translated a little bit. And I can do the same thing with the cube root function as well. It would just be translated a little bit. So I don't think I can grab both of these at the same time. Let's see here. There we go. So on this cube root function, I could move it down and back and forward, and it's still the cube root function no matter where it is. And so that's why these are called parent functions, because it doesn't matter where they go, they have the same shape. So if I'm asked to graph y equals 1/2 x, the square root of x, then what I could do is compare it to y. So I would take this guy right here. This is my square root of x function. And it's going to look like this about. And so if I look at 1/2 x, then think about what you're doing. You're basically taking 1/2 of each y value. So if I look at my x and y chart, at 0, I'm at 0. But remember, we're taking 1/2 of the square root. So at 1, I'm at 1/2. And then at 4, I'm at 1. And then at 9, I'm at 3/2. So I lose a half each time along the way. So what's happening is I start off at 0, but then at 1 I'm only at a half. And then out here at 4 I'm only at 1. And then out here at 9 I'm at 1.5. And so what we've got is a square root curve that's growing at half the rate. It's still a square root curve. It should match up if my drawing is any good. They should be really close to identical. Well, my drawing's terrible, but they should be pretty close to the same exact curve. One's just going to be up at the square root part, and the other one's going to be half that size. Okay, so again, domain and range. Okay, the domain and range for this guy, it's going to be the exact same, from 0 to infinity on both. And so that's your parent functions. That's how they work. And then we're going to look at a few examples of these guys. Okay, so our first example now is looking at a cube root, the -3 times the cube root of x, and compare that with y equals the cube root of x. So drawing off of what we saw a minute ago from our cube root of x, what we're going to have is, I'll put it in black, we had 1 and 1, we had -1, 1, and then way out at 8 we had a 2. So I'll tell you what, let's mark these off as half units. So we'll move this guy back right there. So there's 1, 1, and then we'll go out here, 2, 4, 6, 8, 2, and 2, 4, 6, 8, 2. So here's our cube root graph. It's going to look something like this. My drawing is terrible, but it's a cube root shape. So if we're going to do the 1/3 of the -3 times the cube root, well, let's remember what our original cube root was. So at -8, it was -2. At -1, -1. At 0, 0. At 1, 1. And at 8, it was 2. So if we look at those same numbers again, and let's graph this guy in blue. So we'll graph this guy right here in blue. Then basically what you're looking at is with the same XY chart, but you're looking at -3 times those numbers. So at -8, we'd be at -6. And at -1, we'd be at -3. And at 0, we'd be at 0. And at 1, we'd be at -3. And at 8, we'd be at -6. And if I do my math right, a negative times a negative is positive. So those would be positive numbers there. So when I graph this guy, it should flip itself around. So at -8, I'm at 6. So 1, 2, 3, 4, 5, 6. And then at -1, I'm at 3. And then 0, 0. And then 1, -3. And then 8. 1, 2, 3, 4, 5, 8, -6. So this graph is going to be something like this. Okay. It's not the prettiest graph I've ever drawn, but it's not bad, and you get the general idea, and that's the important part. But it's still the cube root graph. It has now just been reflected over that x-axis and stretched out a little bit wider. All right, so we've seen that if you are wanting to graph these guys, the shape stays pretty much the same. So just a couple of things that will help us get through this, and that is this. Number one, if you're going to graph x minus the square root of a times x minus h plus k, then what you're going to do is graph the y equals a square root of x graph. And then you're going to move it horizontally k units and vertically h units. And notice it's a minus sign under the radical. So kind of think to yourself, super secret opposite society. If it's inside the parentheses, you're going to do the opposite of what it says. So if I have something like, say, y equals 3 times the square root of x minus 4 plus 7, then the plus 7 part takes me up 7 units. Okay, so we're going to move that part up 7. The minus 4 part in here, since it's the opposite of plus 4, it follows this pattern. So since it follows that pattern, we move the h units. Well, in that case, we just take just the 4, and we're going to move to the right 4, because that 4 is a positive number, and all the right side numbers, all the positive numbers move to the right 4 units. And we'll look at an example of this. The same thing happens with the cube root. Whatever value you get for k, this moves you up and down, and whatever value you get for h moves you left and right. So let's see how that's going to look. All right. So graph negative 2x minus 3, square root of negative 2x minus 3 plus 2. Well, what we want to do is we want to look at the graph of y equals negative 2 times the square root of x. And then this minus 3 right here means we're going to move 3 right. And this plus 2 right here means we're going to move 2 up. And so this is how this graph is going to work. So we can make an XY chart. And remember, with the square root of x, we wanted numbers that we could use that made nice, pretty square roots. So we were going to use 0, 1, 4, and 9. Now remember, the first time it was 0, so that's okay. And then 1 times negative 2. Square root of 1 times negative 2. And that's going to be negative 2. And then the square root of 4 is 2, but times negative 2, negative 4. Okay? And then the square root of 9, that's 3, times negative 2. Okay? That's negative 6. So this particular graph is going to be at 0, 0, 1, negative 2, 4, 1, 2, 3, 4, negative 4, and 9, way out here at 9, negative 6. So my graph will look like this, and this is much better graphing. Okay, and then what we're going to do is we're going to take this graph and we're going to move it 3 units to the right. So take the whole graph and move it 3 units to the right. So let's just clone him, and we'll make the clone a different color. And we're going to go 3 units to the right. So here's 1, 2, 3, and then 2 units up. 1, 2, and this then right here in green, this is the graph of y equals negative 2 square root x minus 3 plus 2. And the orange part down here is y equals negative 2 square roots of x, and that's not the same color, orange. So that's all there is to it. Don't let that part be super hard or challenging. It's the same graph, it's just been moved. Well, you can do the same thing with the cubic, okay, with the cube root. And so again, on this, when we look at it, we go, all right, we want to graph the part that says y equals 3 times the cube root of x. And then we're going to move 4 units left. Now, how did that happen? That happened because we have minus -4. And remember, according to our rule, this needed to be a minus sign on the inside. We're also going to move 1 down. And that's this guy right here. Okay? So again, when you graph, you want to think about numbers that have cube roots. And we've been using -8, -1, 0, 1, and 8. So the cube root of -8 is -2 times the 3 is -6. The cube root of -1 is -1 times the 3 is -3. The cube root of 0 is 0 times 3 is 0. The cube root of 1 is 1 times 3 is 3. And the cube root of 8 is 2 times 3, which is 6. Okay. So when you graph this guy, and again, I'm going to count by 2. So 2, 4, 6, 8. And then down 6, 2, 4, 6. Counting by 2s this time. And then 1, and then 3. And then 0, 0. And then 1, 3. And then 8, 6. So 2, 4, 6, 8. 2, 4, 6. So the graph is going to look something like this. This 1, 3 point, though, is no good. I want to redo this. This guy right here needs to be right here. So I'm going to have a graph that looks like this. Okay? And so how do we graph the green part? Well, what you're going to do is you're going to take the graph, and from its original parent function, you're going to move 4 units to the left. So we're going to move to the left. 1, 2, 3, 4. And then we're going to move 1 unit down. 1 unit down right there. And when you're done, you still have the cube root graph. But now it's 4 units left and 1 unit lower. So what we've done on both of these graphs is we've taken this point that's at the origin, and this particular point has moved 4 units left. So 1, 2, 3, 4. And then he's moved 1 unit down. I moved us too far, didn't I? I forgot we were counting by 2s. So he's going to move about right there. So my arrow's still moving. Whoa moly. Let me see if I can get my arrow to catch my cursor. 2 and 1. Want to see 2 and 1 right there. Okay, perfect. Exactly what I didn't want it to do. Right there. Let's get that guy out of the way. So I got a little ambitious with my graph, but he should be right here. 1 unit lower and 4 units to the left. So anyway, that's all you're doing. It's not a terribly long thing, although thanks to my cursor, it looks horrible. But you just move that. You just move each point 4 units left and 1 unit down. It's not hard. A little bit of practice. Put it on your calculator and eyeball it a few times, and everything will be great.